Okay. Whoops. This is supposed to say 8.1 and 8.4. Got to change it. All right. So, the key to this unit that we're doing so far, I've said before, is you need to be able to factor. If you're still struggling with this, you need to hit MATLAB. Watch the video online, factoring trinomials. But even that is more for the harder ones. Most of these are simple guess and check ones, so you really just need to practice them. Okay? So if you're having trouble with this, go back and work your evens from your homework assignments, your practice pages. Okay, so 1A, you factor the top. So obviously there's going to be n and n. You're looking for two numbers that multiply to give you 24 that differ by 2. That's going to be 6 and 4. And so we want it to be negative. One's going to be positive, one's going to be negative. That's how we know they're going to differ by 2. And this tells us we want more negatives. Then we factor the bottom. This is going to be n, this is going to be n. Two numbers, now this time they're going to add up to 211. So it's going to be 6 and 5. 6 times 5 is 30, 6 plus 5 is 11, and negative 6 and negative 5 is negative 11. Now, before we do any canceling, remember, what are the excluded values? You base that on this fraction right here. So you set this and this equal to 0. N minus 6 equals 0. And remember, we write n can't be 6. And n minus 5 equals 0. N can't be 5. Now we cancel, and our final answer is n plus 4 over n minus 5. Number 2. Remember here you can do whatever you want. You can multiply first and then cancel. I prefer to cancel at least my numbers first. So 4 goes into 16 4 times and into itself once. And 9 goes into itself once, 27 3 times. So that simply leaves me 3 over 4. Now I'm going to look at my letters. So I have b to the first here and b squared over here. That's going to give me b cubed. Then I'm going to look at my h's. I have 1 on the bottom and 5 on the top, h to the 5. Where do I have more h's? On top. How many more? 4. Y's. I have 7 on the top, 3 on the bottom. Where do I have more? On the top. How many more? 4. And that ends up being my answer. There's no more left to reduce. Number 3. Well, remember, factor wherever you can. And also break up your parentheses. So this is x minus 3 times x minus 3 over x minus 4 times x, I'm just pulling out a GCF, x plus 3. And here I have x plus 3, x minus 3. That's x squared minus 9 factor. And now I can cancel this x minus 3 with one of these, and that's why I broke it up. I didn't leave it x minus 3 squared. You could just cross out the 2 if you want to do that. That's fine. That's another way of doing it. It's up to you. And this x plus 3 will cancel with this x plus 3, leaving me on the top a single x, an x minus 3, and x minus 4 in my denominator. Number 4. I have 2x minus 3. I'll do this one just to show. Leave that like that. Times x and x. I need two numbers that multiply to give me 3. Have to be 1 and 3. That have 4. Well, that's 1 and 3. Everything's positive. And down here, I have the difference of two squares, 2x minus 3 and 2x plus 3. And if I wanted to, I could just write this as one big fraction also, because anything on the top will cancel with anything on the bottom. So this 2x minus 3 will cancel here. This x plus 3 will cancel with one of those, leaving just the 1. And what am I left with? X plus 1 on the top, and at the bottom, an x plus 3, and a 2x plus 3. And that's it. Number 5, I'm going to pull out a GCF of x and get x plus 4. At the bottom, I'm going to factor this into two parentheses, x and x. I need two numbers that multiply to me 8 that add up to negative 6. That's negative 2 and negative 4. And then over here, x and x. Two numbers that multiply give me 2, 2 and 1. I need more negatives, so negative 2 and positive 1. And then here, I'm going to pull out a 3x squared and give me x plus 4. So this x plus 4 cancels with that x plus 4. This x minus 2 cancels right there. This x will cancel with one of these x's, leaving me 3x on the bottom. So at the top, all I'm left with is x plus 1. And at the bottom, I'm left with 3x times x minus 4. On to number 6. This factors 2x, and two numbers multiply give me 15. That's 5 and 3. They have positive 8, so they're both positive. This is the difference of two squares, x minus 3, x plus 3. Remember, when you have two primitive squares and a subtraction, they factor into the square root of both terms, 1 plus, 1 minus. And then I have an x plus 5 and an x minus 5. Notice, the x plus 5s are both on the top, so they will not cancel. The x plus 3s will. So what I'm left with is x plus 5. I can write it twice, or just put this. X minus 3, x minus 5. And very important to remember that this and this cannot cancel. They're both on the top. Number 7. Now, notice division. So I'm going to rewrite this as x squared plus 7x minus 18 over x squared plus 9x when I change this to multiplication. So I can, think about multiplying by that. Now I'm going to factor. So x squared, 8x is negative 20. X and x. I need two numbers that multiply give me 20 that differ by 8. That's going to be 10 and 2. I need more positives than negatives. On the bottom, I'm just going to pull out a 5x squared, which will give me x plus 10. Times, or I can write it all in one line. Two numbers that multiply give me 18. That differ by 7. Well, that's going to be 9 and 2. I want more positives than negatives. On the bottom, I can only factor odd and x. That's it. And now the fun begins. X plus 10s cancel. Remember, the x minus 2s do not. X plus 9 cancels. And remember, this x cannot cancel with those because they're both in the bottom. So what we're left with is x minus 2 squared, or we could write it twice, over 5x cubed. X squared times x to the 1. And there's our answer. Number 8. I'm going to change this to times x plus 3 over x squared plus x minus 6. So we have an x plus 7 on the top. On the bottom, I need to factor x and x. I need two numbers to give me 14 that differ by 5. So that's going to be 7 and 2. I need more positives to have 5 left over, 2 negative. And then x plus 3 over here on the top. And then x and x. And I have two numbers that differ, that multiply to give me 6, that differ by 1. That's 3 and 2. I need more positives than negatives. Now we play. X plus 7, x plus 7, x plus 3, x plus 3. What that leaves us with x minus 2 squared, or x minus 2 in parentheses both. But what's left on the top? Nothing's left, but we can't put a 0, because that would be 0. So we need a placeholder, which is 1. Moving on. Okay, number 9, we need to have a common denominator. We do. Didn't have it writing every time. Some of these ask you to do it, but you should be doing it every time. Since we already have a common denominator, it's just a straight addition. 2x plus negative 3x is negative 1x. And 9 minus 9 is 0 over 6x. Now, we can cancel the x's because there's no addition or subtraction going on. So this is just simply reduced down to negative 1/6. On number 10, remember, we have to factor everything first. So I need something to multiply, give me 24, that differs by 2. 6 and 4. I need more positives than negatives. So my LCD is 3, x plus 6, x minus 4. I look at the first fraction and I say, hey, what do you need to become this? We need the x minus 4. And the second fraction, what do they need? Just the 3. So multiply by 3 over 3. So on the left, I need to FOIL, or distribute, my 2x plus 1 and x minus 4. So 2x times x is 2x squared. Now I'm going to do both these kind of in my head. 2x times negative 4 is negative 8x. Plus 1x is negative 7x. And negative 4 times 1 is negative 4. Plus, on the right side, 3x. Now for space, I'm not going to write my denominator because I need to simplify terms. So negative 7x and 3x, 2x squared, minus 4x, minus 4, all over 3, x plus 6, x minus 4. And that's my final answer. Number 7. First off, let's change this to adding negative 1x, or just negative x. My LCD is going to be 3x times x minus 4. Sorry, plus 4. So this first fraction needs an x plus 4, top and bottom. And the second fraction needs a 3x. Again, multiply. So I need to distribute my 7. Remember, this is not 7x plus 4. This is 7x plus 28. Distribute it to both. And then my negative 1x times 3x is going to be minus 3x squared. Now I just reorder it. Negative 3x squared plus 7x plus 28 all over 3x times x plus 4. Okay, number 12. The LCD is just simply both parentheses, x plus 4, x minus 4. So the first one needs an x minus 4, top and bottom. And the right one needs an x plus 4, top and bottom. And once again, when you do this, remember, distribute the 5 to both items. So that's 5x minus 20 plus 2x plus 8. And again, I could write x plus 4, x minus 4 at the bottom, and then rewrite everything again, but since I know how much I'm going to be combining, 7x minus 12 over x minus 4, x plus 4. All right, moving on. Almost done. So, this right here factors to x plus 6, x minus 6. LCD. Well, here's the problem. 6 minus x is not the same as x minus 6. So remember, we can rewrite this as x minus 6. We just need to take out a negative, which we're going to put up here with the negative 2. Now my LCD is x plus 6, x minus 6. The left fraction is okay. It already has everything it needs, so it's 5x plus 4. Minus, now remember, because we need an x plus 6 here, so we're going to distribute negative 2 to both of these. So minus 2x, and very importantly, minus 12. And I already drew the line, so I might as well write it, I guess. X plus 6, x minus 6. Now I simplify. 5x minus 2x is 3x. 12 minus negative 12 plus 4 is negative 8 over x plus 6, x minus 6. That's it. Okay, we have a subtraction problem, so why don't we just do this right off the bat. Make that plus negative 2 over x plus 5. This is going to break down to x plus 5, x minus 5, and the difference is 2 squares. So what's our LCD? X plus 5, x minus 5. Meaning the first fraction is fine. This just needs x minus 5 to be done. So we have 3x minus 5 minus 2x, careful, plus 10. 3x minus 2x is 1x. Negative 5 plus 10 is plus 5. Over x plus 5, x minus 5. And look what happens here. Those cancel, which leaves us with just 1 over x minus 5. And now the last two, which are not as scary as they look. Remember, this means divide. So there's two ways to do this. I can go ahead and go directly to what the problem is going to look like, or I can write it out long ways first. 4x over x plus 6 divided by x squared over x squared plus 3x minus 18. But if I know this means divide, I know I'm just going to change the multiplication, so I could go right to this. 4x over x plus 6 times, and just go right to the flipping. X squared plus 3x minus 18 over x squared. It's up to you. Some of you might go right to factoring this also. So this is going to become x plus 6, x minus 3. And now I can factor, or cancel. X plus 6 cancels. This x is going to cancel with one of those x's. So what I'm left with on the top is just simply 4 times x minus 3 over x. And remember, you cannot cancel those two x's because of this minus sign. Very important. That's your answer. And here we go again, same idea. 2x squared minus 3x over x plus 2 squared. I'm just going to go right to my times and flip it. X squared minus 4 over x squared. If you need to write it out step by step as a division problem first, that's fine. Now I'm going to factor. I'm going to pull out x and get 2x minus 3 over x plus 2 squared times x plus 2, x minus 2 over x squared. And now the fun begins. This x plus 2 will cancel with one of those x plus 2's. This x will cancel with one of those x's. So what am I left with? Well, on the top, I have 2x minus 3 over x minus 2. On the bottom, I have x times x plus 2. And that's it. So, again, if you can do this worksheet comfortably, you will be fine on the quiz. This is a very good representation of what will be on the quiz. You just have to keep track of the basic ideas. Okay? So, for example, number 1, remember, excluded values are always based on the simplified fraction before canceling. Number 2, remember, cancel your numbers before you multiply if you can, if you have smaller numbers to deal with. And then just ask yourself a simple question. Where do I have more letters, top or bottom, and how many more, to find out your leftover exponents. Once we get into 3 on, the multiplication, remember, all you're doing on the rest of these, 3 through 6, okay, 3 through 6, is factoring, 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 canceling, and then writing what's left over. On 7 and 8, remember, being that it's a division problem, we just need to change the multiplication and flip that second fraction. And then again, it's just like 3 through 6, factor, 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 cancel, simplify, clean it up. For 9 through 14, remember, we need an LCD. You need a common denominator to add and subtract fractions. So find out after you factor what the LCD would be, and then ask yourself, what do I need to make each denominator match the LCD? And then multiply by that, top and bottom. Remember, like on number 11, if you have a plus on a subtraction problem, or number 14, change it to addition and move the negative to the top. And number 13, if you have two binomials that are close, like x minus 6 and 6 minus x, you can take out -1 and make them match. And then you just put that negative up to the top. And on 15 and 16, all you're doing is really just rewriting that as a division problem and then as a multiplication problem. So study your factoring, should be good to go.